In this video, we'll be walking through applying the properties of exponent to simplify expressions. Here is the first example. So we're going to use this, basically this procedure. I call it PPNQ steps. That's the order in which we are going to apply the properties, the PPNQ step. If there is any power that is involved, like you have power of power, we will do that first. You have a power and then you have another power, we will do that first. And then after that, we're going to do the product. We will try to collect all the variables into one base, similar variable into one base. And then after that, we will apply the negative exponent property. And lastly, we will do the quotient. So it's a good practice to go through these steps like in order in which it's listed. All right, so let's see how it works with this one. So as we can see, there's power of power involved because you have this parenthesis and then the exponent on the outside. So the first thing I would do is to apply the power of power to the expression. So let's go ahead and do that. So these three over here, this power applies to every single element inside the parentheses. So the first thing I would do is to that -2 must receive the power, the x must receive the power, the y to -2 must receive the power. In that case, it multiplies. So 3 times -2 is -6. Okay, so we've done the first part of the expression. We go to the second part, which is I'm going to highlight that in yellow. This part, we have to be careful. Anytime you see a negative in the front of a variable, that negative is actually -1. So we're going to treat it as -1. So that -1 will receive the power of 3, and the z will receive the power of 3 as well. Okay, now in our expression, there's no more power that is involved. So we're just going to copy the other part of the expression the way they are. We're just copying them. Okay, now we've copied everything. All right, so we've done power. So power is done. We're going to do product now because we can see there's there is x and then x over there, and then there is y. We're just going to combine all of this into one, consolidate them into one base. So first, let's take care of the number first. So we have -2 to the power of 3 is -8. So we'll do that first. That's -8. And then the -1 to the power of 3 is -1. So -1 times -8 actually becomes just 8. So the negative goes away. So we're done with the number. Now let's go to x. So here we see x as exponent of 3, another x with a -3. And now, so according to this product rule, we are supposed to add the exponent like that. So we're going to add -3 plus 3, -3 plus 3 is going to be 0. So x is going to have 0 power, 0 exponent. So let's do that. X is now 0 exponent. And now let's go to y. The y has -6 and 1. Whenever there's nothing there, is 1 really. So let's just put a 1. There's a 1 there with a y. And then there's a 2. So we're going to do -6 plus 1 plus 2. That will give us -3. So that will be -3. So our y will have a -3 exponent. So let's write that. Y is now -3. Okay, now we're done with the y. We go to z. There is the z, z to the third, and another z to the first over there, and another z to the second. So if you add all those together, the 3 plus the 1 plus the 2 will give us 6. So give us 6. So the z will have 6 as its exponent. Z becomes 6 as the exponent. So actually I left this 4 out. There's a 4 right here that need to be accounted for. Let's account for that 4. So we need to multiply the 8 by 4 as well. So be careful not to miss anything. So this is the negative 2 to the top power is negative 8. Negative 1 to top power is negative 1. Negative 1 times 8 is 8. And then times 4 is 32. So the number should be 32 in the front like that, 32. Okay, now we're ready to, so we've done power, we've done product. Now we're going to do the negative exponent. So because there's a negative involved. All right, so it's advisable to have like a fraction bar drawn to take care of opposite sides. So the 32 has no negative, so it's just 32. Now x to the power of 0, x to the power of 0 is actually 1. So 1 times anything is the same thing. So that can be ignored as 1. So x to the power of 0 is just 1. So I can just say, okay, it's 1, it's gone. Now this y to negative 3 has a negative exponent. It has a negative exponent. Has a negative exponent there. So that means it's going to be, we're going to take reciprocal of y to negative 2. So it will be y to the third at the bottom, at the denominator, y to the third. So every time you do, if you do y to the third, it's actually 1 over y to the third. Y to negative 3 is 1 over y to the third. And that places that at the denominator. So that's why it goes to the denominator. And then the z to the 6 is positive exponent. It stays at the top right there. So we're almost done. Actually, we are done. We just need to write it properly. So our final answer is just 32 z to the 6 divided by y to the third. All right, that's example 1. There is another example here that involves a fraction at the beginning. Okay, we're going to apply the same rule. We're going to do the power first. We do the power, then we do product, then we do negative, and then we do quotient. All right. Now, here is the power involved. So we need to take out the power first. Let's try to do that. So negative 3 squared. So that 2 applies. This 2 applies to every single thing inside, okay? And then we go to m. So m to the 6, the 2 multiply the 6, it becomes 12. So it's m to the 12. And then we just copy everything the way they are. There's no rush. We copy everything the way they are. And then this is the 6. We are not changing anything now. So in class, remember I told you the way to eat elephant is to eat 1 bite at a time. Okay, so it's the same thing principle here. Just take your time to do 1 thing at a time. So now we're going to do negative 3 squared, that's 9. So the top will become 9. And then now, if there is nothing to apply the power product with at the top, because you have only one m with only 1 single base, and n 1 single base, and p 1 single base. The same thing downstairs. So we don't need to do anything with the power yet. So we can just write it. Write that. Let's just write the 9, and then we can actually apply the negative now. So let's follow the process. So there was no need to do product yet. There was no need to do product, so we're going to do negative exponent. So here is negative exponent. Now, the m to the 12th, this m to the 12th is positive, so it stays where it is. M to the 12th stays at the numerator. The n, this n has a negative exponent. It has a negative exponent, so that's a negative exponent there. It needs to go downstairs, go the opposite side. The same thing with the p, negative exponent. All right. And then, so let's put those two down first. So it's going to go down as n to the fourth and p to the fourth. Okay, we're done with the numerator now. So we go down to the denominator. This is 6. We need to write the 6. This is 6 down here. And then the m to the fifth. The m to the fifth is negative exponent. So that's a negative exponent. It goes upstairs. It's go to the numerator. Okay, so it's going to be m to the fifth, and then the n to the negative 1 to the power of negative 1 is also a negative exponent. It goes to the other side. It goes to, I call it upstairs. It goes n to the first power over there. The p is positive exponent. The p is positive, so it stays where it is. The p is positive. Whenever it's positive, it just stays where it is. So p to the sixth. Now, we have done the negative. Now, that kind of leads us to the next step where we can see, we need to consolidate the variables. So we want to have only one m, only one n, and so on. So let's do the, let's make the variables just one with one base. So 9. So we have 12 and 5 upstairs. That will be 17. And then n to 1 power. At the denominator, this is 6. And there's an n to the 4th. But the p will be 4 plus 6. That will be p to the 10th. And now we can see, we can apply the quotient property now. Right now, there's only one variable that is involved. That's n. That's the n. This n has 1 at the top, and it has 4 at the denominator. So we need to subtract and keep it at where we have the larger exponent. We're going to subtract and keep the resulting expression where we have the larger one. So we are going to have, let's do the 9 and the 6 for. Let's simplify 9 and 6. So that will be 3 and 2. So it will be 3 over 2. And then the m stays where it is. And then the n, we're going to take 1 from the 4, and the denominator will be n to the 3rd. And then the p stays where it is, p to the 10th. It looks like a long process, but actually it's really fun to do. It's not too hard. And that's the answer to that. Now we go to another example here. So I'm going to talk less and just show the process. I'm going to follow the process. So the process will be 2 to the 3rd. Applying the power property first to everything, like that. So it will be x to the 9th and z to negative 12. And then the negative 1 goes to every single thing. All right. Every one of them gets a negative 1. So it will be times 2 to the power of negative 1. Y to negative 1. Z to negative 1. X to 4, because negative 1 times negative 4 is 4. And then we can just draw the bar and put everything down there the way they are. Okay, now we're ready to use power property to kind of get them, with only one of each variable at the numerator and denominator, only one of each. So 2 to the 3rd is 8. That's 8. Okay, there's an x to the 9th over here. X to the 9th. There's a 9 here. And there is a 4 there. That will give me x to the 13 at the numerator. Okay, we're done with the x. We go to the y. The y is only 1 over there, so it's just y to negative 1. And then the z, there's a negative 12, and there's a negative 1, that's a negative 13. Negative 13. And then there's a 2 to the power of negative 1 there. We should not forget that. So everything needs to be accounted for. And then at the denominator, there's a y to the 3rd, and there's a y to the 3rd. That's a y to the 6th. And then there's only one x to the negative 1, okay? And a z to the 2nd. and a z to the fourth. And that will be, this is negative 2. Sorry about that. Negative 2 and 4 will give me 2. Z to the second power. And then there's a 2 by itself. So there's a 2 by itself. Now everything is accounted for. Now we're going to do the negative exponent now. We're going to switch them. So let me highlight what's going to switch. This is going to switch. Everything with the negative will switch to the other side. And these are going to switch. The rest are going to stay where they are. So let's do that. The 8 divided by 2 is 4. Let's say 4. Now let's do all the switching. The x to the 13 stays where it is. The y goes down as 1. Z as 13. And then there's a 2 to negative 1. And then the denominator already has a y to the sixth and a z to the second. So we're almost done. Now we're going to combine, if there's anything to do. Oh yeah, there's a little mistake there. That 2 comes down as 2 to the power of 1, not to negative 1. Okay, got it. So now the 2 here, we cancel the 2 there. That will be 2, final 2 there. And x is just only one base there at the numerator. There are 2 bases for y here. We need to combine them. So it's a 1 and 6 becomes 7, y to the 7th. And there's a z to the 13th and z to the 2nd. That will be z to the 15th. Okay, and that's it. That's it for that. Now the last example is this, where we have the power that applies to every single thing. So I will do that first. I'm going to apply this negative 2 to every single thing. All right, so we're going to have p to negative 4, q to the fourth, because negative times negative is positive, divided by m to the negative to negative 2, p to negative 6, because negative 2 times 3 is negative 6, negative 2 times and that one is q to negative 6, m to negative 4, p to the fourth, because it's a negative and negative, and then q to negative 8. So then we're just going to squish all of the variables to one power now, just one power. So let's use product for that. The numerator stays the way it is. All right, and then the denominator needs to be squished into one, into each of the variable into one. So m, there's a negative 2. There's a negative 2 and a negative 4. That will be a negative 6. Negative 6. And there's a p now. We go to p. So p, there's a negative 6 and 4. That's p to negative 2. P to negative 2. And then a q. There's a q to negative 6 and q to negative 8. That's q to negative 14. And now we're ready to use the negative exponent property now. Okay, so let's move everything that has negative to the other side. Highlight everything that has negative. They are going to move. This is going to move. The p down here is going to move. The q is going to move. All right, so at the denominator, yeah, okay, let's just move everything first. So the p to the fourth come downstairs. The q to the fourth stays where it is. So we're done with the numerator. Now we go to the denominator. M to the 6 goes upstairs. And p to the second goes upstairs. And q to the 14 goes upstairs. Now we're almost done. So we're just going to combine them all now. So the q, there's a 14. There's a 14 and 4 for the q. That will be q to the 18th. So q to the 18th. Remove that. So q to the 18th divided by, there's an there's an m. Okay, the m to the 6th. Okay, And then this p is 2 up here and a 4 down here. So we need to subtract and keep the answer with the where the larger number is. So it will be p to the seconds. So all this expression really boils down to this last expression down here. Well, that's how you simplify expression applying the properties of exponent.